Good evening, everyone. I hope that you are enjoying these classes. Now you see here, exams are going to approach very near to in the June cycle. So due to some health issues, so that I haven't taken any classes last week. But from this onwards, little we have to move very fast. Like I will be taking two classes per day. Okay, morning one and afternoon one. Or else I will be uploading at before 10 o'clock. Okay, 10 p.m. daily. And now I welcome you all for the LAChem Institute classes. LAChem Chemistry Institute. Chemistry classes. Okay, now here you see, in our last class, what we have seen is we started organic chemistry. Okay, in our last class, we have started our organic chemistry. In that, we completed concept of hybridization. We analyzed syllabus of CSIR, and with respect to gate, how we have to prepare simultaneously. And what else? We also completed how to identify molecular orbitals, hybridizations in organic molecules, not in inorganic molecules. Only in organic molecules we have seen. So today that is completely organic portion. So in that organic portion only, I will be taking here today new chapter. That is what? Molecular spectroscopy. Okay, that is what? Molecular spectroscopy, that I am starting today here in this. Okay, we will be seeing this molecular mass. Okay, you can say molecular, but mass spectrometry. Mass spectrometry. Now you see, as we have studied in our degree and as well as in our PG, that there are so many various types of spectroscopies are there. Okay, there are so many types of spectroscopy, like UR spectroscopy, UV spectro, sorry, not UR, UV spectroscopy, and NMR, HNMR. Okay, carbon dating. There are so many techniques that how to study a molecule, how to study a atom. But here we see that this is not a spectroscopy and this is spectrometry. Okay, just remember this. There is a lot of distinction between spectroscopy and spectrometry. But in spectroscopy and as well as spectrometry, we are going to know about the molecular structure and their internal things. Okay, internal things, how they have arranged, what is weight of that all we are going to study in them also. But that is completely different from this. You will be understanding this in this class. Now you see, what is metry? Okay, mass is nothing but what is metry? Spectrum means okay, spectra, metry. Okay, first metry is nothing but instrumentation. Spectrometry is nothing but instrumentation. In this instrumentation technique, in this spectrometry technique, mass spectrometry technique, I am always saying that MS here. Okay, I can't say that mass spectrometry, MS. In mass spectrometry, we will be seeing, okay, it is first it is not a spectroscopy. It's not a spectroscopy. Okay, where in which absorption of energy. Okay, absorption of energy takes place. Okay, but whereas in MS, nothing but mass spectrometry, there is no such absorption of energy. there is no such absorption of energy is observed. Okay, observed in this technique. Now in other UV or HMMR spectroscopies, there is a utilization of electromagnetic resonance, okay, energy, EM, electromagnetic R, resonance spectroscopy. Okay, there we use, this is the energy source, but whereas it comes to in this, we use electron beams. Okay, electron beam, we use, see, I am not saying here electron beam nothing but light. Okay, bombardment of electrons, you can say bombardment of electrons can be done. Bombardment of electrons can be done in this technique. Now you see, so this is what bombardment of electrons can be done. Example, now you see how it is. Now for example, if a molecule is A, B, C, D, okay, this is a molecule. On this molecule, now electron energy, okay, electron energy that you are applying, these are all electron, so they are now reaching them. Okay, they are now, the energy is reaching them. Okay, energy is reaching. When this energy hits to the molecule, what happens? The bond between the atoms breakdowns, and finally we get new fragments. We get what? A, B, C, D. Okay, A, B, C, D. These are the fragments that we see. These are the pieces. Okay, these are the pieces. Fragment nothing but piece. Fragment is equal to piece. Okay, fragment is nothing but piece. We used to get, these are the pieces. So after studying these pieces, we get to know what kind of, after studying nothing but after assembling. Okay, now you see, we disassembled. Okay, now after assembling this A, B, C, D, we can be getting to know that what is molecule actually it is. Okay, what is molecule actually it is. Now in this technique, sample cannot be regained, retrieved or retaken or gained back. Okay, sample can't be, okay, sample can't be retrieved. In this technique, sample can be retrieved. This is one of the disadvantage that we can say. But the sample amount is, the amount of sample, amount of sample is utilized in this technique is less than, okay, less than 0.1 milligrams or less than nothing but you can say 0.0001 milligram also you can say. Okay, this is very important. Okay, this is very important. For example, if a sample is 1 milligram of sample, if it costs 2 lakhs rupees, can it be very simple? No, whenever you are doing lab, some experiments in the lab now, it is very costly. The each and every sample that what you have is, it is very precious. It is very precious. Wait. It is very precious. Now, in that case, we use only milligram. This is advantage also. One is a disadvantage, one is advantage. So, when we are destructing the molecule, we can name this mass spectroscopy, mass spectrometry is destructive technique. Okay, destructive spectrometry also you can say. Destructive technique or destructive mass spectrometry also you can say. Since we are breaking the bond, these are lysis, we are doing lysis nothing but breakage, cleavage, you can say cleavage. Okay, cleavage. Okay, you are doing lysis or cleavage of the molecule, and then you are getting the some fragments, and we are studying that fragments. According to, when we assemble all the fragments, we get this. Now let me recall, this is first, it is not a spectroscopy. First point, it is not a spectroscopy, it is a spectrometry. In spectrometry nothing but instrumentation, metry nothing but instrumentation. In that instrumentation, there is no absorption of energy takes place, whereas in UV NMR, there in those, there is a absorption of energy is taken place. For example, there when you take any NMR a sample in NMR tube, and then when you keep that into the NMR device, okay, NMR device, that sample can be retaken back. But when it comes to spectrometry now, since it is already, okay, completely broken pieces, it can't be, it can't, it just just disappears. Okay, it just disappears, this molecule completely disappears. So that is what mass spectrometry is. In that case, electromagnetic resonance we are not using in this. Okay, that is what we are using, only electronic beams that we are using in this mass spectrometry is. Okay, this is, hope that you understood up to here. Okay, now we'll be going applications. Okay, applications of mass spectrometry. Take 1 minute and pause your video, and up to here you copy. Okay, copy, or else you will be forgetting this after some days. See, this is the question. Okay, this is a question of DL. In DL, this is a question. Okay, this is a question. Now you see, in this, now we have seen what is the instrumentation. Okay, what is the instrumentation? Now we are looking that applications of mass spectroscopy, mass spectrometry. Okay, applications applications applications, okay, or usability, you can say, utility, you can say, where we can use this. Okay, number one, to identify the structure of the molecule. To identify structure of the molecule, to identify the structure of the molecule. Next, two, in identification of of molecular weight. Identification of molecular weight. Okay, in identification of molecular weight. Now, identification of molecular formula. Molecular formula. Identification of molecular formula. In identification of molecular formula. Now, in identification of molecular structure, nothing but in identification of molecular, it can be a skeleton structure, it can be a branched skeleton, okay, it can be a branched skeleton, it can be a cyclic molecule, it can be any cyclic molecule, okay, it can be a polycyclic molecule, okay, it can be a polycyclic molecule, it can be also polycyclic molecule. The molecule which structure it is, we don't know, but when we bombard or we collide, you can also say collide, we get to know that what are the fragments. For example, here we can get these fragments, okay, we can get these fragments, okay, we get these fragments, okay, we get these fragments, something else, okay, in this. And these fragments can be in identification of smaller molecules. Fourth one is in identification of smaller molecules. Okay, like you can say atoms also, but here you see I am using the word molecule because like sulfur, chlorine, bromine, iodine, okay, alkane, CH3, this kind, okay, this so many ether, epoxides, so what not organic molecules, ether, epoxides, okay, aldehydes, ketones, you can all write, okay, CHO, okay, CO, ethers, okay, anything that you can take up, okay, to identify their structures, okay, their structure. This is what applications of the mass spectrometry is. Application of mass spectrometry. Pause your video for 1 minute and then you can note down this, okay. This is what applications in with applications, nothing but where we use, okay, where we use this method, for example, now you are just sitting in a experiment lab, okay, you are in a lab, now you have worked on some kind of you worked on some kind of experiment, okay, that you extracted some product, you don't know what product it is, okay, and you wanted to know as to submit your thesis, okay. So before that you must have to have a overall history, what is the product, okay, what is the structure of it, what is reactivity, okay. Once we know the history of the product, then only we are going to have further studies on it. So where we can use that, whether it is organic or inorganic, okay, whether it is cyclic or non-cyclic, whether it is heterocyclic, okay, how we are going to know, because if we use this technique, then we will be knowing that what the molecule is, okay. To study that we have this technique, that is what mass spectrometry, okay. In that case now you listen, and this is what is mass spectroscopy utilities, applications. Now hoping that you are noting this, okay, or else you will forget. Now we see here in general principles, okay, we see general principle, okay, principle, heading is general principle. Okay, general principle of this. In this general principle, first we have to see the instrumentation. Now we'll see, this is sample. This is what? Sample. Now tell me, this sample can only be used, okay, can only be used in gaseous state or evaporated state. For example, if your sample is solid or liquid, you must have to bring it into the solid, gaseous state or the evaporated state. You can't use here liquid state directly or solid state directly. You must have to convert into gaseous state before bringing to the chamber of spectrometry. Okay, that is what very important, and this is also a question of DL. Okay, this is also question of DL. Sample, you write here gaseous state. Okay, gaseous state, gaseous in state. Now in this sample, I am using word here sample. Okay, when you apply, this is not energy, it is electron beams. Okay, electron beam. When you are applying this, here there is a formation of molecular ion. Okay, molecular ion. Now here you see, this is what the structure of molecule. Okay, this is what the structure of molecule. These are electrons. Okay, electrons, molecule structure, molecules. Now when this light collides inside, okay, one electron ejects from its shell, outer shell, and there is minus one electron. Okay, minus one electron, and now there is a formation of molecular ion. This is what? Formation of molecular ion. Okay, this is what? Molecular ion. You better say, you can say this is molecular ion. Molecular ion. This is what? Very important. This understanding molecular ion is very important. Now you see, this is what? Molecular ion. See here, ionization potential. Here we have to, I'll be explaining here. Ionization potential. Ionization potential. Nothing but ionization potential is nothing but removal of energy. Okay, energy which is required to remove one electron from its outer shell orbital. That is what? Ionization potential. Now how much ionization potential that we have to have, that I will be telling you in further. Now you just have to understand this, what is ionization potential. For example, nothing but, this is orbital, this is electron. Okay, so this is nucleus and this is electron. Okay, this is very near to nucleus. So the energy which is required, to eject this electron from the orbital. So that is what? Ionization potential. Now we have seen that S, P, D, F black group elements. So in those, for example, if the S group elements, electrons are very near, very near to the nucleus. So electronegativity, you say, when electronegativity is very attracting towards it to the nucleus, okay, nucleus, then it can't give as simple as it is. Okay, remember this. So this is what ionization potential is. Now after this, what happens is there is the formation of molecular, okay, there is a fragments of ions, okay, fragments. This, don't say this is also molecular ion, this is also molecular ion, but that is not, that is very different. This is formed from the molecular ion, okay, this is formed from the molecular ion, okay, this is molecular cation, okay, this is molecular cation, this is neutral, sorry, this is neutral molecular ion, this is molecular anion. Okay, so you see this, the species can be anything, okay, these are fragments, okay, these are fragments, these are fragments. What is this? These are fragments. In this, now you see, mass spectrometry is specially designed for to only study the molecular cations. Okay, cationic species can only be studied in this mass spectrometry. Now you see, neutral molecular ion can't be, I can't say this, neutral molecule can't be studied here. Negative, there is one also here, spectrometry, negative spectrometry is there, but it is not much useful, okay, but it is not much useful. Here we can, any molecular ion, if it is charged positively, that only be studied under this mass spectrometry. This is very important point, okay, this is very important point, okay, understand. This is very important. I will dictate you, no problem, but you understand this. Okay, this is what sample and this is what is general principle is. Now write down one thing. Now the required energy is, electronic potential is 70 electronic volts, 70 electron volts that we required to, okay, to convert sample, okay, to convert molecule to molecular fragments. Okay, I am not using this molecular ions to this, okay, that also we will be looking. Okay, now write down general principle. First point, sample should be in, okay, first point, sample should be in gaseous state. Sample should be in gaseous state. And the sample should not be in the liquid state or solid state. Sample should not be in the liquid state or solid state. If the sample is in solid state, or liquid state must be converted into gaseous state or vapor state, gaseous form or gaseous state or vapor state before entering into the mass spectrometry chamber. Before entering into the chamber, this is what. Now molecule, draw this molecule. Now write down next point. After drawing this, write down next point. Ionization potential. The energy which is required to remove one or electron, to remove the electron to remove the electron from its outer orbital or outer shell. Its outer orbital or outer shell. That is what? Ionization energy. You draw this picture also for your better understanding. You draw this picture also. Now, one more point. Now write down one more point. Now, mass spectrometry is especially designed to study the fragments which has positive charge, simply you can say cations. You can also write cations. To study the mass spectrometry is specially designed to study the cation species. Now write down under note. ये mass spectrometry can't study or can't analyze. Mass spectrometry can't study or not designed for or not useful to study the neutral atoms, neutral species or negative species. Okay, for them there is another negative spectrometry is technique also there. Hoping that you understood up to here. Now see here. Now you see here. Okay. Now, for example, write down. First listen. The energy, for example, now CH3 plus. This is what the our fragment. This fragment can be okay. This fragment can be. Now CH3 CH2 plus. Okay, this can be. Now how to calculate their mass? Now you see, we know that carbon which is belonging to the fourth group element and its atomic number is 6. Carbon is 6. Okay, carbon is 6. 6 into 2 mass. I am not saying that electron counting. I will also saying that electron how to count, but here mass 2 into 6 12. Okay, 2 into 6 12 plus 3. 12 plus 3 is how much? 15. 12 plus 3 is 15. Now what is m by z value? Okay, what is m by z value? M by z value. Okay, m by z value or ratio, you can say ratio. Okay, ratio. M nothing but mass. Okay, mass. Okay, charge upon mass. Okay, mass of the molecule and charge of the molecule. Okay, charge of the molecule. Now you see what is mass of the CH3. Okay, carbocation. Now what is this? Carbocation. A carbocation mass is 15. Okay, 15 by charge. What is the charge? Single charge is there. So 1. Okay, what can we write here? 15 by 1. This is what? 15 by 1 nothing but again 15. So this is what m by z value of carbocation. Now we see. Can you calculate for this also? Can you calculate for this? Now CH3 CH2 positive. Okay, m by z value. M by z. Now what is mass? Mass is 2 carbons. 2 into 6 12. 12 into 4. 12 into 2. Okay, 24 by 1 we have. Okay, 24 by 1. But hydrogens are there. So how many hydrogens? 5 hydrogens. Plus 5. Okay, nothing but 29 by 1. 29 by 1 nothing but 29. Okay, this is m by z value of, this is m by z value of CH3 CH2. Okay, ethyl cation, you say that ethyl cation. Okay, see, this is what, hoping that you understood why this 24 comes, why this 24, you know what, carbon is belonging to the fourth group element and its atomic number is 6. Atomic, to calculate mass we have to double it nothing but into 2. 6 into 2 12, 12 plus 3 nothing but 15, 15 by 1. From where this one charge came? Because of 1 plus charge. Now let me tell you, if CH3 plus, okay, plus is there. Now tell me, now do this for me. Now do this, plus is there. So 15 by 2 plus charges are there, nothing but 2. Okay, nothing but 7.5. This is what m by z value. Okay, m by z value. Okay, you can calculate for plus 3. Okay, plus nothing but plus 2, no. Plus nothing but plus 2, plus 3, plus 4 also. Now write down here, write down this, write down this one. Heading is m by z value. Okay, m by z value. Charge upon mass. M is here mass of the molecule and z is charge of the molecule. So you are writing this. Okay, you are writing this. How to calculate the mass of a molecule, that you are calculating in this way. Now singly, first point, okay, singly you are singly you are, for a singular charged, write down, for a singular charged ion, z value is 1. For a singular charged ion, z value is 1. For a double, okay, for a double charged, doubly, you can say doubly, okay, doubly charged ion, m value is nothing but 2. Okay, if the triply charged ion, nothing but plus 3. If it is plus 3, that is nothing but 3. Okay, z value is 3. If it is 4, quadruply nothing but polycharged, multiply charged more than 3, that is what, 4, 5, 6, so on. Now you see, now you tell me why positive charge. Okay, carbon has how many electrons? Electrons, that concept I will be taking you later, but up to here you listen. 4, it is having 4 outer shell electrons, and these are hydrogens. We have, these are hydrogens. Now in this, you see, how many we convert. For example, you just have something, you just have cleavage. Okay, this carbon, methane, okay, sorry, methyl, it lasts 1 electron, okay, 1 hydrogen, then it is now CH3 plus. Okay, this is nothing but loss. Okay, if it is plus 2 charges there, then nothing but it lost CH2 plus 2. Okay, CH plus 3. Okay, C plus 4. You said this, it given all these electrons. Okay, it given it all electrons. So that is what, based upon charge, that we are doing this. Okay, it is very important. Hope that you are understanding this. Write down quickly. Write down this quickly. Now you see here, now you see sample, we have written that point. Now 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 you see how to identify the graph, how to identify the graph. Hope that you noted this, how to identify the graph, how to identify the graph. How to identify the graph. Now you see the plot is something this, plot is something this. Okay, intensity of molecule, intensity of molecule, intensity of molecule. Okay, intensity of molecule, intensity of molecule, m by z value. Okay, m by z ratio, or you can say m by z. Okay, m by z ratio. Okay, m by z ratio. For example of cation. Okay, of cation, m by z of cation. Here you see, if the peak is this, okay, see intensity nothing but stability. Okay, stability, intensity is nothing but stability. Now the graph can be this way. Okay, now graph can be this way, graph can be in this way. Now you see here, if the height of the pole, if the height of the peak, height of the pole, you see if it is greater, if it is greater, this is peak, we say base peak. Okay, this peak is base peak, base peak, this peak is base peak, this peak is known as base peak. Now this peak is known as, this peak is known as parent peak, parent peak, this peak is known as parent peak, or molecular peak, or molecular ion peak, molecular ion peak. And these all peaks, okay, these peaks, even base peak, okay, this peak, these four peaks are known as daughter peaks. Okay, daughter peaks. Okay, daughter peaks. This is what you have to remember this. For example, if for example, if this higher the stable, if the stability of the carbocation is high, then its peak is very high. If the lower the peak, then its stability is very less. If the higher the stability, the lower will be the fragmentation generation. If the lesser the stability, higher will be the generation of fragment. If the generation of fragment happens very simply, okay, very simply, then that only is very useful to study the molecules. Okay, to study the molecules. If the generation of the fragments can't be done properly, then that sample is not for any use, and we can't study the sample perfectly. Partially we can study, that we will be discussing after now. Okay, after this we will be discussing. Now you see, up to here you are clear. Okay, you understand, if the peak, higher peak is known as base peak, and the lower, this last peak, okay, last peak is known as parent peak, and the other, this side peak is known as, all are known for daughter peaks. So that is what you have to identify. This plot is between versus intensity of molecule versus mass by charge. Okay, mass by charge ratio. Okay, this, hoping that you understood this, hoping that you understood this. Now you listen here. write down heading, write down heading, write down heading, write down heading, molecular ion, molecular ion, molecular ion. The heading is molecular ion. This is molecule. Okay, this is molecule. We have given 70. Okay, we have given 70 electron volt energy, and now it became positive, sorry, radical ion. Okay, radical ion. Now molecular ion, this is what? Molecular ion. If you understand the concept of molecular ion, then you will be understanding rest of spectrometry very simple. Molecular ion, and this molecular ion further divides into these many species. Cation, molecular cation, neutral molecule, negative, okay, radical, okay, radical, anything, okay, radical. Now you see here the energy, okay, energy, the maximum, okay, the maximum number of molecules or compounds, maximum 80% of organic compounds, 80% of organic compounds, they form molecular ion at, they form molecular ion at 12 electron volts only. 12 electron volts only. They form at 12 electrons volt only. And now we see here the energy, if you give energy molecule to convert molecular ion, if you give energy 17 to 15 electron volts, if you give the energy from 7 to 15 electron volt, you will be converting molecule into molecular ion, but not the fragmentations. This process can't be done because of insufficient energy is given. Okay, insufficient energy is given. The required amount of energy that to be split or that to be form fragmentation is not provided. So most of the 80% of the organic compounds yet 12 electron volts, they will be generating molecular ion. Okay, now tell me, what is the maximum energy that is required? Now question, what is the maximum energy that is required to provide or to generate molecular ion? Answer, option A is 70, B is 7, C is 15, D is 20. Okay, now your option is obviously 15. Okay, your option is obviously maximum the electronic energy, electronic energy that given to generate molecular or molecular ion, that is what? 15 electronic volts. That is the concept of this. Now write down the point. This is very important. Write down, very important. the maximum electron volt of energy is required to generate molecular ion is 15 electron volts is 15 electron volts. is 15 electron volts. Now we see maximum 80% of organic compounds. Now here I will be bringing you this when now maximum 99% of the, now here I am bringing the concept of electrons, okay, species, okay, these are species. 99% of organic molecules, they are even electron species. I am not saying even mass electron species, even mass species, okay, even mass species, even electron species. 99% of organic molecules are 99% of organic molecules are even mass, even electron species, even electronic species, nothing but even electronic, nothing but. Now you understand carbon. Now this is carbon. Carbon is, what is carbon charge? It is belonging to the sixth group element, fourth group element and sixth atomic number. Its atomic number is 6. So now you see its outer orbitals are filled with 4 electrons. But S group element is also having how much? 2 electrons. 2 plus 4. 2 plus 4 how much? 6. 6 plus hydrogens 1 electrons. Okay, hydrogens 1 electrons. Hydrogens 1 electrons. Each 4. 6 plus 4. Okay, 6 plus 4 is 10 electrons. 10 by, you know, right, even number. If the number is divided or if it divides by 2, that is what, and it gives product 2, then nothing but that is what even electron. Okay, this is, if you divide this, you will be getting it is divisible by 2. It is divisible by 2. This is 5. Okay, that nothing but is nothing but even electron species. Even electron species. Even electron species. This is even electron species. Now this, now you see this is even, okay, even in organic. Now you see organic molecule. This is organic molecule. Just imagine this is organic molecule. This is organic molecule. What is this? Organic molecule. This is even electronic species. Even electronic species. Even electronic species. Now, even electronic species is very highly stable. Okay, this is stable. In any compound, if it is unstable, we can't study it. Okay, what? We can't study it perfectly. So, as to study it, we must have to take to the excited state or, okay, unstable state. So, this is what unstable state. It lost 1 electron. Okay, now it is waiting for 1 more electron. Okay, it is waiting for 1 more electron. So, this stage is unstable. Okay, unstable. Okay, unstable state. In this unstable state, okay, in this unstable state, we can generate what? Number of fragments. We can generate easily generation of, in this unstable, generation of fragments is very easy. Generation of fragments is very easy. Now you see here, at this level, generation of fragments is very easy. Now, this is what about the organic molecules. But now when it comes to inorganic molecules, when it comes to inorganic molecules, when it comes to inorganic molecules, now you see here, now you see they are, just imagine this. Okay, sir, you are writing here, 2 dots, nothing but that is, even. Okay, that don't think that I am using here molecule, not electrons. Molecules. Okay, molecule. This is molecule. This is electron. Okay, now you see odd. Okay, odd electronic species. Odd electronic species is, okay, odd electronic species giving, and this is odd electronic, inorganic molecules in odd state, they are highly unstable, they are highly unstable, they are unstable, and now they are giving what? Stable, okay, stable ion, they are giving stable molecular ion. So this stable molecular ion is not very easy, okay, it can't generate, or it is very not, it is very not a simple that to generate fragments, it can't generate fragments. When there is no generation of fragments, we can't study the molecules, okay, we can't study the compounds, we can't study the molecular formula, so we can't generate the structure of the compound. So finally this mass spectroscopy is not useful for the, and maximum it is not useful for the inorganic compounds, it is only useful for the organic compounds. That is why we study this in organic chemistry only, not in inorganic chemistry. Mass spectrometry we don't study in inorganic chemistry, we only study in organic chemistry. So up to here you may be having no doubts, okay. If at all you have doubts, you can contact me, okay, you can contact me, I will be giving clear idea. You can, you know that my number 918 22 32 585 816 86 222 91. You know this, you can directly contact me. Your contact time is evening 8 to 10, okay. You can reach me out through WhatsApp. You can also keep your you can post your doubt in WhatsApp, both numbers you can post WhatsApp, or you can say directly call me in this. Hoping that you understood. Now write down, write down that molecular ion, okay, molecular ion is in organic compound, molecular ion is in even electronic species, after, okay, after providing electron 70 electron volts, it got converts into molecular ion state, which is very unstable in nature, 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 which is very unstable in nature. Now that molecular ion, this molecular ion can easily generate fragments, can easily generate fragments. Once the fragments generated easily, once the fragment 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 generated easily, we can study the compound or molecule, we can study the molecule very easily. Now one more point, 99 or maximum percentage of 99 or maximum percentage of 99 or maximum percentage of organic molecules, 99% of organic molecules, 99% of organic molecules, they are in even electronics, they are even electronic species. They are even electron species. They are in even electron species. Write down this. Okay, write down this. They are even electron species. They are even electron species. They are even electron species. Write down this. Write down this. Write down this. Write down that. Now you see, when one electron is removed from the molecule, there is a formation of molecular ion. 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 Okay. Now we see in inorganic molecules, they are odd electron species. They are odd electron species. They are odd electron species, and they generate stable molecular ion. 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 And this stable molecular ion is okay, can't be generating very easily fragments. Okay, very easily fragments, and that is leading to not, or we can't study, that is leading to improper study of molecule. That is leading to improper study of molecules. That is leading to improper study of molecules. That is leading to improper study of molecules. Write down one more point. As the stability of molecular ion increases, already we understood this concept. As the stability of molecular ion increases, as the fragmentation decreases. What happens? Fragmentation decreases. Now you imagine, we can't change the shape of iron when it is in stable form. Nothing but when it is cold. When we heat it and when we liquefied it, we can turn its shape. We can bring in which shape we want to change. So that is what. See, if you imagine this is iron, okay, this is iron or anything. This is also, you just see, this is what? Plastic. Okay, this is plastic. Now it is having one shape. When you give some overheat, it can be changed into liquid state, and that liquid state is, you imagine, this is unstable state. Okay, unstable or transitory state. In that stage you can convert it in any form. Okay, in which form you want, you can make from it this marker, you can make any chair, you can make any stool, any kind of such anything. So this is what mass spectroscopy introduction. This is what mass spectrometry, I am very sorry, mass spectrometry introduction. This is what mass spectrometry introduction. Now what we have seen is, first we have introduced what is mass spectrometry, and then applications of mass spectrometry, and then general principle of mass spectrometry. And in that general principles we have seen organic molecules and inorganic molecules with respect to spectrometry and their functions. And in our next class we will be going to study with respect to the bonds. For example, sigma bond. Sigma bond nothing but whether it is covalent bond or coordinate bond, metal bonds, okay, pi bonds, okay, nothing but we have the electrons are there in HOMO or LUMO, okay. HOMO nothing but you are understanding, okay, HOMO, LUMO, highest occupied molecular orbital. So that you might be have studied in chemical bonding. If not also no problem, we will be studying that in our chemical bonding. From tomorrow I will be uploading two classes by 9 o'clock, okay. Shravya and Bhagyalakshmi, Shravya and Bhagyalakshmi, you remember this, okay. If at all you have any doubt, you can watch this video again, and further in upcoming classes I will be clearing your all the doubts. And Suman, you also, so do this. That is what this is what is all about our first class. So that tomorrow we will be seeing that unstable, okay, those of the compounds. This is the number you note down, and this is what. Thank you for watching this video. You do one thing. Exam is going to maybe held in this June cycle, okay. So you have to quickly revise, okay. CSIR, you have to quickly revise the notes, simultaneously. Don't keep this in pending after completion of our whole course, okay. That I will be revising by sitting this is not at all impossible task. It is impossible task, and next to impossibilities, you can't make it. You can't score good marks in CSIR. For example, if this unit is completed in 10 classes, you are from today onwards, you are revising this, okay. When you are attending tomorrow's class, you must have to revise this class and then attend, okay. That is what that you are doing, okay. Likewise, organic, inorganic and physical, okay. In first class only I told you that I am not dealing physical chemistry. Maybe I will be helping in some of the chapters, but I cannot deal physical chemistry in deep. Organic and inorganic, that we will be dealing very sincerely here, okay. Thank you very much.